Yesterday you invested sinusoidal graphs on your own to see that sinusoidal graphs, when you're dealing with y equals sine theta, looks like these waves that are here. Y equals sine theta, make a different color here, is different than our y equals cos theta because it always starts here at the origin 0, 0 for our basic graph, and then our key points happen at 90 and 1, 180 and 0, 270 and negative 1, and 360 and 0. So those are our key points that we want to worry about. And those are ones like when you were doing your parabola y equals x squared that you could do really quickly without having to do a table of values. Now you can see here, stopping at 360 and 0, that's one full cycle. So where it goes from here, up, down, and back to its original spot is a full cycle of y equals sine theta. What that means relative to our last unit, when you have your initial arm, it means that this initial arm rotated from here all the way around 360 degrees. You can see here it went from 0 to 90 degrees, right there, and then from 90 to 270, so it's mimicking this wave here on the Cartesian grid. Okay, so we'll continue to clean this up here. Just going to move my slide down a little bit. So you can see now y equals sine theta is similar, but it's different. When you're y equals cos theta, excuse me. It's similar to y equals sine theta, but it starts up here at 0 and 1, and a full cycle comes down, back up at 360 degrees there. So that's one full cycle of y equals cos theta. Our key points here, you can see, is up here, 0 and 1, 90 and 0, 180 and negative 1, 270 and 0, and 360 and 1. So it's good to keep those in mind, again, when you're doing your transformations, that you don't have to do table of values. All right, I have our sine graph here, and now we're going to do some transformations to it. I've extended our y-axis a little bit. In your notes, you'd use a ruler, and it'd be neater and easier to see. But I'll give you an idea, a reminder from our quadratic unit of what you're going to do. So our a value here is negative 2. So at negative 2, that means that you're going to take all of your y values and multiply them by negative 2. So we're going to have a reflection in the x-axis as well. So you can tell our key point here at 90 and 1, if we take the y value of 1 and multiply it by negative 2, it's now going to be down here. Okay, our points at 0 stay at 0. Anything times 0 is just 0. And our point here at 270 and negative 1 times negative 2 becomes positive 2. So it's going to be up here. Sorry, so it's going to be up here. So our points now are going to come down, back up, into the 360. So you can see that there's been a vertical stretch in the y-axis and also a reflection over the x-axis. In your notes, your graphs will look the same size. The bottom trough of my red graph got a little bit skinny, but when you're using graph paper in your own notes, it'll be more visible. So we have one more transformation to do of our plus 3, and our plus 3 here is our q value. Right there, that's our q value. And remember, that means to move things up or down 3 units. So it's going to be hard to tell exactly here on ours, but this point here at 0 is going to move down to 3. So if we had it on the x-axis here at 3, we would have a point there, and so on and so forth. Oops, excuse me, I was moving that down 3. So our points will be up here. Everything will get moved up 3 units. So from this point here, we'll go there. So essentially, on your graph, what you will see is something similar to this, where our equation of the curve happens at positive 3. When you're doing your transformations in your notes, everything will be a little bit more clear, and we'll also work on it in class again tomorrow. But this just gives you a reminder of how the transformations work. We'll look at a cos graph to do transformations as well. Our equation here is y equals cos 3 theta plus 180. Now our biggest problem year after year is the students continuously forget to factor out that 3 theta. That 3 has to be outside the bracket. So what we have is theta plus 60 degrees. So if you forget to do that, you're going to be transforming your graph 180 degrees to the left when you're really supposed to be moving it 60 degrees to the left. Now keep in mind with your k value, you're going to multiply your x values by the reciprocal of that. So your x value of 90, you're going to multiply it by 1 over 3, which now becomes 30 degrees. So your point here that was at the 90 is now going to be at 30 degrees right there. So that's our new point for our transformation. And for 180 degrees here, this point is going to now be at 60. So you can see how you're going to have a compression. And then our point of 270 divided by 3 now happens there at 90. So our graph starts here, comes down, back up through the 90. There you have it. You have a compression in your x-axis, so our graph became more narrow. Now you would take all of these points, use a different color here, and they all need to go 60 degrees to the left. Just extend this. So our point here that's right there comes over 60 degrees. This point here that's at 60 will be right there. Everything comes over 60 degrees. Again, on your graph paper, much easier to see. When you're doing your transformations, it's just fine to show one cycle like I did there, and then be sure at the end that you label your colors so we know that's your final graph of 3 theta plus 60 degrees. Here's what I leave you with now to do a reminder of transformation and an introduction for our activity for tomorrow's lesson. So it's really important that you, in your notes tonight, using your transformations of what I've just reminded you with, do this graph here, y equals 3 sine 4 theta plus 100 plus 2. Now it's already factored out for you, so you don't have to worry it. So what you have is a vertical stretch by a factor of 3, a horizontal compression by a factor of 4. It's going to go left 100 degrees and up 2. So start with your basic sine theta graph, do all of your transformations to it, and then do your best to answer these questions about your very final graph. What's the amplitude? What's the equation of the axes? What's the period? And what's the phase shift? It's important you come with all of this attempted tomorrow in order to start our activity together in class.